Hey guys, in this video, we're going to discuss Leetcode 2265 to count the nodes equal to the average of the subtree. So basically, we're going to be given the binary tree, and we're going to return the number of nodes where the value of the node is equal to the average of the values in the subtree. So the keyword here is a binary tree. So for binary tree, it means like every node will have a maximum of two child nodes, the left and the right. And we need to find the total number of nodes where the value of the node is equal to the average of subtree. So let's take a look at example here, example 1. So we have this tree, and the total sum for this tree is 24. And we have 6 nodes in total. So the root node has a value of 4, right? So 24 divided by 6 is 4. So root value is equal to the average of the root tree. And then this node value of 5, and the sum of the subtree is 11 divided by 2 nodes in total, and which is 5 as well. So this 5 is equal to the average of the subtree. And the same for this one, it has only one node, so the average value is equal to the same of the value of the node itself. Its value is equal to the average of subtree, and the same for these 2 nodes. So all the 3 leaf nodes, and then the root node and this node, node 5, are the nodes with a value equal to the average of the subtree. So this is a standard tree problem, and usually for tree problems, we're going to solve that recursively. And while we're doing the recursive function, while we calculate every node on the recursive call, what we need to do is like we need to return a value for the return a set of values for this node, for this function call on the node. So in this case, since we need to calculate the average of the subtree, so what we need to return for every node is like we need to return the total number of nodes in the subtree and the total sum of the subtree, and then like the number of nodes equal to the values in this subtree. So basically, the key idea for this program is to design the recursive function while we do the DFS on the binary tree. So let's define the recursive function. So define def DFS, and we're gonna traverse on the node recursively. And so when we design when we traverse a node, right, what we need to return is like we need to return 3 values. So one of the first one is like the total sum of the subtree, and then total number of nodes, and the number of nodes that meets the requirement that value equal to average. All right, so basically now we know for this function we need to define like the total sum and the total number of nodes, and the response is like the nodes meeting the requirement we need to find. So let's define the edge case as well. So if not node, then we return total number of sum is like 0 and then 0 and 0, right? So we have 0 nodes with the sum 0 and then 0 nodes meeting the requirement. Now we need to traverse the left node and the right node. So total sum left. Give me a second. Let me just do this. Total sum left, number of nodes left, and the response left will equal to DFS on node dot left. And then we can do the right one as well. Traverse on the right node as well. All right, so now the total sum would be equal to, for this node, like the total sum of the subtree would equal to the left plus right plus the current node's value. Plus node.bar. And the total number of nodes will equal to left, right, and the plus 1. Total nodes left, and the response value, like the number of nodes meeting the requirement, will equal to the left plus right. And also we need to calculate if the current node meeting the meets the requirement or not. So if node dot val equal to total sum divided by total number of nodes, then we're gonna increment the response by 1, because the current node also meets the requirement. So basically, this is a recursive call we wanna return. So basically, now we need to find call the call on the root node, DFS. Let's call it recursively on the root node, and then we just return. So the first two return values will not be used anymore. So we don't care for the root node for the previous two values. Yeah, and then we just return the response. Let's see how it goes. Yeah, looks good. Looks good. All right, let's call the recursive function. Yeah, looks good. So yeah, so this is the actually the algorithm function. So basically, we need the key point. The key point for this problem is to define the DFS recursive call, and we need to know like what we need to return for each recursive call. Since like the key problem is to find the nodes like have an average value equal to the have a value equal to the average of the subtree. So we need to return for every recursive call, we need to return the total number of sum of the subtree and the total number of nodes in the subtree, and then like the nodes meeting the requirements in the subtree, and then like we can, when we do the recursive call, then we can just use these three values to calculate the current value to see if it meets the requirement or not. So yeah, and the time and space complexity, like because it's a core stack, so the space complexity would be order of n. Like basically, the stack core would be maximum number of nodes, or maybe log n, like the height of the tree if it's average. So and the core stack would be like we traverse each node. So it will be order of n. Basically, we traverse every node one time. Okay, so this is the end of the video, and I'll see you guys in the next one.